Hi, good afternoon, everyone. Welcome to the training session today. There are about 8 of attendees who have arrived as of now. Please make a small roll call, raise your hands, or let me know via chat that you have arrived. I see Pankaj Mishra and Sharad Chandra raising their hands, or you can write to me on the chat window as well. Manjunath. So let's wait for another 2 to 5 minutes. Hi Pankaj, let's wait for a while for others to arrive and we shall soon get started. So we have people joining today. Welcome to you. I welcome you all and we hope today's session is exciting as yesterday's was. I hope all of you would have seen a little bit or gone through some of the PDFs and other links that I had shared yesterday. Uh, those those are some of the PDFs which I believe are the best, to start with, and then obviously we can, choose our choicest, fields to move on into our respective work fields. So we are going to continue where we left yesterday. Let me know in case there are any doubts, concerns. If you're not able to hear my voice, do let me know. So we have a few of the participants who have been very, interested, and I have that from yesterday's logs. Uh, so we are going to look at some of the uh, features and some doubts you had yesterday Name node high availability was one of them, and I do have it right now itself. So if you say, we can start off with the name node high availability and look at other features. Uh, from the introduction to Big Data PDF, let me just show the today's content that we are going to see. So you would have it on your screen now. So I have shared the table of content that is to be done today, and the same was also shared yesterday. So in these 4 hours, we are going to devote some of our time into distributed file systems. And for those who have understood the working of a distributed file system, which is through HDFS, should be able to work on other DFSs also, which include ClusterFS, okay, and then we had Ceph. I told you about Ceph. Uh, Yahoo, when it was acquired, last year or probably last to last year, I remember Yahoo tweeting in 2005 or 2015 April that it has moved to Ceph distributed file system. So we know that HDFS was prevalent in Yahoo prior to 2015, and they adopted Ceph distributed file system. So any of you having the mail on Yahoo would eventually be going on Ceph file system. So today's share, I've shared two documents as of now on the share, which happens to be, if you could just look at the shares today. Let me just tell you which new documents have been shared for today. There is one on distributed file system and another is on cluster architecture. So have a look at those while we move on with today's session. So let me know if you come across any disturbances, any issues. I would be happy to address those. And continuing with today's agenda, we have ClusterFS, introduction to Hadoop, then introduction to HDFS. So since the introduction to both of these was mostly covered yesterday, I would restrict my introduction part for these two today, and we can have that time to indulge into more advanced activities. For example, MapReduce applications and working on Spark and so on and so forth. So again, coming to Hadoop, we have two broad things today. One is the name node high availability, which I'm going to shortly tell you about. And the second is the Cloudera virtual machine, which is the latest one. So the link that I had shared in the chat window yesterday, I believe you would have downloaded the CDH virtual machine and started working on the same. And so for that, I'll be doing some demonstrations on the Cloudera virtual machine. So let's wait for some more time and see the attendees can arrive, and then we move on. So we have 25 out of 52 people who are there as of now. And I think we are 10 minutes over. Let the others join, okay? And I think we can, move on. So let me have your consent in the chat window. Let me hear from all of you in the chat window if we can move on. Great, let's get started. Yes, please. All right. Yep. Okay. Chaitanya says yes. Joshua was the first one to arrive. So kudos. And okay, let's hear from you all if we can move on. And so first thing I would like to show was the where we left yesterday. All right. So yesterday we were working on the introduction to distributed file systems. And if you remember, one of you had asked me to demonstrate the high availability on name node or the HDFS high availability. So in the broad sense, HDFS high availability is when the nodes go down and let's say the name node goes down, because name node is the one that stores the metadata. So I'm going to share again my VMware so that we can now have a look at uh, the name node high availability. So see, the scenario goes like this. On your screens, you would be able to see uh, 4 virtual machines running. Okay, one is elephant, another is tiger, horse, and monkey. So these are the 4 virtual machines. And out of these, elephant happens to be the name node. Okay, so as you can see, when I do sudo jps, it shows it is the name node virtual machine. The same thing when I go in and do on another VM, let's say horse, for example. So we see data node being run out there. Okay, and the same goes for monkey as well. So I'll do sudo jps. So there it shows that the data node is running. Okay, so just to reiterate some concepts since yesterday, uh, from yesterday, there is communication happens between name node and data node, right? As soon as we did start DFS, the name node would start the name node process, okay, over here. In particular, we are talking of the process, which is a Java process. We're not talking of the hardware and the server. So when we did start DFS, it starts name node process on the main server or the metadata server, and simultaneously it starts the data node processes on all the data nodes, which is available in the slaves file. So in this case, we have 4 nodes, okay, and from the 4 nodes, as we have seen, on monkey we have the data node running, on horse we have the data node running, on tiger we have the name node running and data node. Okay, so on tiger, data node is also running, and then on elephant we have the data node as well as the name node running. So we have all the 4 nodes as data nodes. Okay, and to confirm this, we'll start the web browser and go back to see the port number 50070. So let's give the same port number by giving either localhost, or I could have done elephant. So these 4 names of the animals, elephant, tiger, horse, monkey, have been given only to as a label. And so when I give 50070, So it would expect the host name to arrive over here. So when I say the host name, uh, we should probably and positively just put the name, the host name in this field. So because the local host sometimes is not resolved. So that's the reason, why we need to put the host name. So it should have otherwise been localhost.local domain. But anyhow, so this is the name node. Okay, and let's look at some of the essential characteristics of these virtual machines. I hope everyone can see the VMware workstation window. So we see the configured capacity to be 187.74 gigabytes. Now, why is this? We have about 4 of the live nodes, okay, or 4 of the data nodes that are there. So I'll open this into a new window, and as you see, tiger, elephant, horse, and monkey, last contact. If you recall from yesterday, one of the data nodes had been turned off. Okay, so when a data node is turned off, it doesn't contact name node. So it is the data node's responsibility to contact the name node every 3 seconds. And each of these have been given the same storage. So we see about 46.9, about 50 gig of storage has been given to each of the virtual machines. And it also shows that how much is used. So it's 15 gig is or meg is used from in the tiger, about 18 in elephant, horse, and monkey. So much is used. Okay, and then it shows how much is non-DFS used. So what we usually do is like reserve some portion, okay, for the base operating system or for the host operating system, which is Linux in this case. And so the used less, the total capacity is what it shows as the remaining. So this is the remaining DFS capacity available to us. And so that is the summary of the 4 data nodes that we have, right? And in the main screen, we found the summary of the entire distributed file system, HDFS. One thing, and as I said yesterday, if we would like to use or utilize this huge file system, okay, one possibility is that you go to one of the clients, okay, and I told you about Fuse 3G. If we go to the net and search for Fuse 3G, okay, and HDFS, we will be able to mount this HDFS file system in a client machine. So the command would roughly be something like this. So sudo mount, and then we would say whichever is our name node. So we will say HDFS name node, considering that this is our name node where we have to mount from, and which is the directory that it has provided. So I've just got one chat. So you're asking, is this the single command dfs.sh to start and stop all services, including application and web services? Not really. Start DFS is only to start the distributed file system. Secondly, we use start yarn to start the resource manager. So that is the second thing, okay, that we have to anyhow do. And it is implementation based. In Cloudera, for example, let me show that to you so that it will become very, very clear now itself, because we are on Cloudera virtual machine. The one that I did yesterday for you was customized. Okay, I had downloaded Hadoop from the Apache website and configured it and then made it as a multi-node cluster. But Cloudera implementation is different. Okay, Hortonworks implementation is different. Okay, so it's like Linux only, that the kernel is downloaded from kernel.org. Okay, and then companies are customizing it. So Red Hat, Oracle, IBM, etc. Customize the kernel, okay, Linux kernel, and provide a distribution. And same goes for Hadoop as well. The download happens from apache.org and then you customize it and then push it across as a distribution. So that is how the industry is, and I told you in the chat window yesterday, I mean how many distributions are there. So Mapper, MapR, isn't it? And then Cloudera Hortonworks, IBM Big Insights has been quite a successful distribution, and a few others, okay, have their own Hadoop distribution. So their implementation is different. However, the core concepts remain same. Okay. So for example, when we looked at the slaves file, for example, okay. So like this one is Cloudera. So we have most of the configuration files in etc Hadoop directory. And so let me show you the couple of files there. When we go for conf.dist, see, we have this file called as slaves, right? So I told you about the slaves file, and when we cat this, so it's only showing localhost, which means this is not the active name node as of now. And a couple of others, like you see the core site.xml. So let me show you the core site.xml, which is going to be roughly the same that we had yesterday. So this is the FS default and then some of the essential parameters. Same goes for HDFS. So we saw one parameter in HDFS and we had discussed that. Can you tell me which one's that parameter and the value for it? Anyone on the chat window? Which was the parameter we discussed in the HDFS -site.xml file? Okay, so we have an answer from Neil. He says it's replica and 3. So I'm looking for something specific, more specific than this. So anyhow, let's take this. It is dfs.replication, right? So if I cat this file and see the same in the HDFS side, let's have a look at the dfs.replication in this. Now, or I can do one more thing, which is to grep for replication. Now, so see, replication isn't showing over here. Do you get the point? The replication is not mentioned in the HDFS site.xml file, which means that how much will be the replication factor? It will be default to 3 only. And as I said, we can go to browse the file system. Okay, so this is where we have the browse directory, and what do we see there? In browse we have a temp, user, var. Okay, so let's just go to the temp, and I'm just interested in looking at any particular directory and a file. So see, these are 4 files that are available in HDFS, and let's say that part 00 to 03, each of these are actually MapReduce output files. Okay, so they are of 2.64 megabytes. And when we have a look at each of these, okay, so it shows that only one block is occupied. Now one block, because the default size is 128 megabytes. Even if your file is 2.64 megabytes, uh, it is accommodated within the default block size, which is 128 megabytes. But in the file system, it doesn't take 128 megabytes. It will still hold only 2.64 megabytes. Second case, as seen yesterday, that I made a 512 gigabyte file, or probably the megabyte file. So 512 megs is what will get accommodated in 4 equal size chunks, right? So the other important thing we see from here is the availability. Now, this is precisely what we were doing just now, the replication factor. So replication factor is default, isn't it? grep means to extract replication from the particular file, which is HDFS side, and we see that there is nothing. So replication factor has not been, mentioned in this file. So it will default, okay, to 3, and that is why we see that availability in 3 places, which is elephant, horse, and tiger. So this was to reiterate, the HDFS file system, and um, we can see a couple of other things over here. Uh, but let's now move into the original, uh, uh, the use case where you had a doubt on the name node high availability. Now, we know that the name node, is on elephant, okay, with port number 50070. Name node was also running on another system, which is tiger, okay, but here it is as passive, it is running as passive, okay, it is not active, which means to say that if I open the web browser here and say tiger and then colon 50070, it will not display. So, well, it is showing the name node, but then there is any one of these are going to be active at any given time. Okay, so both of them cannot be active at the same time. So now I'll show you the high availability lab. Okay, now let's look at this. See, this is the standby. Okay, and when you look at elephant, it is showing active. So let me hear from you on the chat if you have rightly understood which is active and which is in standby. Yeah, everyone got it? That one is on standby and elephant is on active. Okay, all good. So Renan says all good. Now, the next thing we are going to see is to fail over this one, and in order to fail over, what we'll do is give a command saying a Hadoop HDFS name node stop. So again, as you have asked, so this we'll do on the elephant. Uh, Somebody is asking something. Let me see. Elephant is active. Yes, elephant is active. So now we'll go to the elephant, okay, and besides this one, most of the stuff, one question, if I copy of file, what is this question now? Neil has asked one question, if copy of file in active node is that all node have same copy mirror? Well, um, Um, see, if you Neil, if you have worked on Linux, okay, I strongly recommend you to have your own Hadoop cluster and do some hands-on. So I haven't quite got your question right, so I'm just reading it out. One question: if copy of file in active node, is that all node have same copy or mirror? So we have seen the replication factor is 3, okay? Now let me just show you copying something on the HDFS. So it'll be like, let's say, Hadoop fs hyphen put etc services to something like slash temp, okay? So slash temp always is going to be on HDFS. And so this is copied in temp, and let me take you to our browsing HDFS, and we'll go to the temp directory. So if one file, if I have one file in active node, is that same copy will be there in standby node automatically? So see, standby node is only copying the metadata. If you really are so interested, I'll show you where is the metadata. So hold on, just hang on, okay? Because we'll break out otherwise. See, this is the temp, and in the temp, I had copied the services file, right? So the services file for the name node is just the metadata. When, let's say you are the client over here who want to access the services file. So as soon as you click the services file, isn't it? It is the request is going to the name node. Always for any input output, the request goes to the name node first, and then the name node propagates that request further to the data nodes. So name node as such is not having any data, but it knows where the file is, just like any other file system. Okay, the real data is inside the data nodes. So name node only has the location, okay, of that file. So let's say it is the services file, and when we require this services file, it will just say that, okay, the block, which is, this about so many kilobytes, and this is the block size. And when I click on this, okay, let's actually click on this and find out where it is available. So see, it is showing availability is in elephant, tiger, and monkey. So which means that the tiger and monkey virtual machines are or the real machines are where the file actually resides. Okay, the data block is actually there. This block ID is the one which is stored as metadata. Okay, now I was telling you about the location of metadata. So there are two files. Okay, one is edits and one is edits. You can note this down. Edits as metadata, and one is fs image. Fs image. So I can find that for you. This is usually in the so let's do a sudo find slash hyphen name, and we'll give, say, edits star. So I probably don't have to do so much because as an admin, what we can also do is find this in the HDFS directory itself. So the HDFS site, this very file, okay, we would have seen the edits directory, okay, and see the metadata. These are the directories which are very much listed over here. So you can see varlib, okay, edits is one file, and we will also find in the same directory, okay, in particular this directory, we'll find the fs image as well. So see there, edits is one file, okay, and fs image as the other file. So both of them have a significance. Fs image is when we initially create the Hadoop HDFS file system. That is when fs image is created, and it's like a one-time write. And the secondary name node also, in our case, Tiger is a secondary name node or standby name node. It fetches this fs image, okay, every now and then from the elephant, and also the edits file. So it is through this metadata retrieval that Tiger will consequently, keep the metadata updated. But this doesn't happen so easily. We have Zookeeper also, which you may have to, learn as well to know how the complete failover happens. So what I'm going to do is I'll just be giving the command to stop this. So what we are going to do is sudo service name node HDFS name node stop. So if you go on to writing the Cloudera admin exam, you will see that Cloudera has, what is the difference in the fs image and edit log? Fs image is one time log file, okay, and the edits is a continuous read write operation, because just now I wrote a file in HDFS which was etc services. So whenever you write or read something, then edits file is, edit. I mean, there is a new edits operation or edit file is created. So you can see there are so many, edits file in this directory. So edits file is very often it is updated. Okay, for most of the read writes, the name node adds, okay, the edits file, whereas fs image is not modified on the fly. It is only read when the system boots. So whenever the name node boots, fs image is read. Okay, that's the main difference, right? So the sudo service Hadoop HDFS name node stop. I'm just showing you what other services we have so that you can check sudo chkconfig and -- list. So see, this is what will show us which all are the Hadoop based services, okay, which are running. Now this comes from Cloudera, right, which is the pioneer of Hadoop distributions. So we can see Hadoop HDFS data node, there is a process, journal node and name node. So these are the two main processes, okay. And so node manager, and there is one called as resource manager. So Hadoop yarn and resource manager, which is somehow not running here, which will be there in other files. The resource manager takes care of the parallel programming, which is MapReduce programming. So this was to tell you about which all services, okay, are running. And now we'll do the high availability failover. Okay, so as soon as I hit enter, which will ensure that your name node has gone down. Okay, so we are simulating failover of the name node. And so now it shows it is stopped. You can see the status. and so well, it's not running. That's why it's showing failed, isn't it? So which means that on Tiger, when we go and do a refresh, isn't it? It should have come active. So see there, it has come active. And if on Tiger itself, you would like to go for browsing the directory, then we should also see the uh, temp services, file, because this is the one which we had just created previously. I hope this is clear for as a demonstration. See, when we go to the theoretical aspects of name node high availability, then it is far too complex. Okay, we got to have Zookeeper, installed, configured, working with HDFS. HBase also requires Zookeeper. So Zookeeper happens to be a synchronization service. Means edits get updated continuously, but FS image is periodically. So I've got a question. Let me have a look at the question here. Pavan says, means edits gets updated continuously, but new FS image created periodically. So new FS image is never even created. Okay, so FS image is like a one-time file, okay, which is initially created and rarely updated. So when it shuts down, then it will get updated. Otherwise, edits is getting okay and edit, yeah, after merging old FS image and edits file. Yes, that is right. So that's what the secondary server does. Okay, so the secondary server or standby, it retrieves the edits from the main server, okay, and it combines the both of these and gives back as a combined file, compiled. So that's right. You must have got it right. Yes. So I'm talking of Hadoop 2. Yes, that's right. So the high availability is only on Hadoop 2. You don't have high availability in Hadoop 1. Hadoop 1, it had to be a standby node and we had to kind of reboot. However, in this case, it is both as a secondary as well as a standby. So you have a real HA, that is as soon as fail the name node, then so next I think we can again start the name node, okay, and see what happens. There is another command called as, I'm just writing that down, HDFS HA admin get service state. So this we can also give on the yeah, probably sudo was more preferable in this. So anyhow, this was to get the state of the server. Now what I'll do is again start our main elephant node. So instead of status, now let's do a start over here and see whether it comes back or not. So that again is very, very, uh, it is basically dependent on the policy, isn't it? So we would go back to this one. So let's Now restart the elephant, okay, and elephant has got started now, okay. Elephant, let's look at the status now. So it's now running, and we'll go back on the main screen and refresh this guy. So see, elephant is going to remain standby, and tiger is going to remain active, right? In tiger, you will see that it's going to remain active all through until we stop the service on tiger. So the very first command that I ran there, okay, we'll now run that on the uh, tiger machine, and you would see that this would come to standby, okay, and the elephant would go as active. So although the elephant has become active, we have to figure out why, on tiger, okay, so the name node has actually gone off, isn't it? And thus we will not have the port number 50070 open. So 50070 is I think in the time wait state. So that is why I think we'll have to just start this guy so that at least it starts to run in the standby mode. And active, of course, if you do a net stat, yeah, it's obviously running, so we'll have the 50070 active. So we have the server, okay, running again. So this is broadly, there in high availability. I would like to tell you about uh, Hadoop 3 has been released. So I will be adding that into your materials. Okay. Meanwhile, let's have a quick poll. Okay, and I'll be adding that to your shared, training share. So I'm just going to send across a poll to all you guys. The poll happens to state which areas are you interested. So I've somehow not mentioned you over here, and I would like to know which areas are you interested in, uh, in working on further. So have a look at your poll screens, all right, and let's hear from you. Okay, I've seen a lot of chats also, and the results for the poll I'm going to share in a while. 53% are interested in database management, 27% into parallel programming, 37% into solution architecture, and so 10% not yet decided, and 7% others. So I've just shared that across on your screens. You can have a look at it. We have 34 attendees, okay, and so I appreciate your response, even for those who have mentioned others and not yet decided, because this is still a growing area, and uh, it's good to explore, okay, explore further. Surprisingly enough, for those who have mentioned database management, uh, presumably are into database management already. So I would suggest, yes, databases continue to expand, okay, and we have today some discussion on NoSQL databases. So if you can get some hands-on to the NoSQL databases, it will be really worth. Okay, so uh, we'll have a look at NoSQL. Parallel programming, I believe those who are into programming and who have good skills into logic, okay, and algorithms, uh, absolutely there is a lot of, I mean, there is more scope in parallel programming, I would say. Taking the market as a whole, okay, providing the logic and algorithms, and the right ones rather, okay, because you would have known a fact that if we have kind of garbage algorithms, then you have GIGO kind of a thing, which is garbage in, garbage out. However, if your algorithms work perfectly for the project, then yes, you are the right fit for that job. Uh, Solution architecture, I found a couple of chats. Let me just refer to those. So one of you is mentioning solution architecture means the same as support database. Not really. See, solution architecture is a very high level job wherein you are expected to know the high level details of the complete solution architecture. I would take examples of, let's say, a telecom industry, okay, or let's say airlines industry. So in general, if you are a solution architect, you are expected to know right from the data center hardware, okay, all the types of servers, storages, and then any of the connected devices, all right, and then starting with the operating system stacks, what possible databases can fit in. And now that big data is there, so people talk of big data projects. Okay, there is a website which I'm mentioning on this on over here. It's called as highscalability.com. So have a look at that website. Uh, we have several of the real world scenarios from this website itself. Okay, has so that's the website I've just mentioned. And if you go through this, you'll find from Google's YouTube, Facebook, Twitter, how many servers each, even WhatsApp. So how many servers WhatsApp has, and which are languages. So I think it eventually ended with 800 servers. It has, created in Erlang language. So you'll get a good know-how from, this particular website. So I'm just referring to a few of your chats. Neil, I replied you on the mail one to one yesterday also. So have a look at that. And it's very difficult to say, you see, because I haven't seen you. I don't know about your skills and experience. So it's really very tough for me to just look at your chat and say that this is the field that's going to be best. uh, if you have more and more knowledge, okay, about things, then you are going to be best suited for one particular job. So have a focus, okay, and keep going. So yesterday I told you that the storage admin experience of 8 years into IBM EMC and the others, including Linux and Windows experience. I think you should go ahead with Gluster FS, knowledge of Gluster, okay, implementation of Gluster and Ceph file systems, okay, and that is mainly the admin side. Hadoop admin jobs are also there in abundance, okay. So that's the core area that I see for you, and uh, big data administration jobs are also in abundance in the market. I mean, depends where are you working and where you are heading towards. So skills and your certification. As per the certification, I would strongly suggest you to look at several options. Yesterday I told about the Big Data University. I'm mentioning that website over here to all of you. This is an IBM sponsored initiative, BigDataUniversity.com. So I have seen this site since 2012, right? And I started with some certifications. Okay, they would give you some certifications. So all you need to do is log into this website, okay, and go ahead working on some uh, data science. So it is tutorials are there, online tutorials, CBTs are there. You can refer to the CBTs, okay, and then there is a test of probably 20 to 30 questions. Again, they are all uh, multiple choice questions, and you get 3 attempts to pass that exam, which is not so difficult. You can very easily pass each of these exams, and then you are given a certificate. Okay, from IBM Big Data University, you are given a e-certificate. It's a colorful certificate. I can demonstrate one odd to you over here also, and that's good to see. So I would like to show one odd which I have attained. Just a minute. So see, I'm just sharing that to you. Okay. Now this is okay. One of the certificates that I passed in 2016 May. Right? Can you see this? Which is also of value, right? This is also of reasonable value, and I'll show one other from Big Data Science, Big Data University itself, and I'm showing you some of the very old one. See that's the Hadoop fundamentals. That's 2014 certificate. Every of these are coming from Big Data University, right? And this is very much an open site. So you are so much welcome to visit that site and complete your certifications. Okay, so let's get back to our working of name node, and now that we have finished the high availability portion, okay, we'll move on into some other aspects. So there is a list of top Hadoop clusters. Okay, so I'll be just referring to those. Uh, so I'm going to share list of organizations with the top clusters. So the organizations with some of the largest Hadoop clusters, I would like to open that now, and let's have a look at that. Okay, and then we'll move on. So see, this is the list of some of the largest Hadoop clusters, and you will be amazed. Actually, Facebook has some bigger numbers. If you refer to the link which has been given in the end, okay, that will give you the real figure. See, Yahoo was at the highest at 42,000 nodes. Number of nodes are 42,000. That's huge number of nodes. Okay, so I just believe there is no one more, zero added. I'm just ensuring that one more uh, zero has not been added, because currently if you look at the present numbers, then Facebook happens to be on the top. Okay, so this is not just so these are very, very realistic numbers. Okay, and these are basically the Hadoop clusters. I would also like to mention a website called as top500.org, which provides top running supercomputers on Earth. So biannually, okay, so half yearly. That is twice every year. So I believe that is in June and November of every year. Or probably June and December of every year. So anyhow, that's immaterial. You can, visit this particular website, which is top500.org, and have a look at the top, running machines on the globe, right? So that was the other uh, area, and that was the other, numbers that I wanted to share with all of you. So I think it's time to move on. Okay, and let me open the presentation and we'll continue from there. Okay, so this was approximately the place we had left yesterday, all right, and let's move on and see some of these. Tell me frankly and honestly, have you gone through any of these file systems individually yesterday? Let's see who is replying. Okay, we have a query if we can have a break. So if you all need a break, we can do it for about 5 to 10 minutes. and then continue. Okay. Okay, so we'll break for about 10 to 15 minutes. 3:20, I should be back, or maybe 3:25. Break for 15 minutes. Okay, shall we continue? Okay, so thanks for your response. I believe we can continue, and others can join in if they are away from the workstations. Okay, so if you recall from yesterday, we had been through these couple of slides and I showed you the Google Public Data Explorer, okay, which sources the data from several different websites, including World Bank and Economic Forum, then US Department of Energy. So these are the several data sources. So sooner or later, when we are working on on big data projects, um, so I would like to ask you, okay, in a poll, I'll shortly be making a poll that what is it that we understand from big data projects. So I would like to hear from you. What is your understanding of big data projects? Because many people, many organizations, would be talking, okay, I have worked on big data, or I have, worked on such and such project. So when we look at the case studies, okay, like eBay is one of the examples. Then Facebook is another example. So these are realistically big data projects in our real world, or in our life. So big data happens to be a small word when we look at such large organizations, okay, like Google, for example. So big data only seems to be a component or a part of such large organizations. Right? So previously, as I had said, that in order to get started with a big data project, okay, which includes eBay, Facebook, Flipkart, okay, Google, Twitter, and it's a list of many such companies, okay, which you can see from the high scalability website, which I have mentioned in the chat window a while back. Okay, so um a while back you would have seen this highscalability.com. I'm once again mentioning that. Okay, so you can have a look at this particular website. It's one real worth website to look at. So you would realize that uh, that most of the work, okay, gets started from distributed file systems, which I have been reiterating since yesterday. Okay, so introducing distributed file systems, which is an agenda for today. Uh, these are the very small quick links that have been mentioned. I would rather like to send these to your chat windows, because as of now you do not have access to your uh, access to this PDF. Hence, I'm just mentioning it over here in the chat window. So let's have another quick poll. Meanwhile, go through these websites. I'll just be preparing two quick polls for now. Okay, so I've just got another poll created, which I'll be sharing in a while. I believe all of us are here and active so that we can continue. All right. Let me hear from you on the chat, please. Okay, Shrikant. Okay, Rupesh. All right, thank you, Radhe, Thakur. Okay, Kalyan. Okay, all right, good enough. So I have just finished creating the poll, and we'll move on into our distributed file systems. So distributed file systems can be, had from the GitHub website. All right, and let's hear from you one more time. I'm just going to send out this poll, and I would like all of you to respond to this. So I've just mentioned this poll. Have you downloaded any project from GitHub? So what I mean is downloaded as well as have you worked on it from GitHub? No, 88% say no. So we have 50% votes. We have about 35 out of 52 participants active. I have only downloaded, not worked. So Robert, so it's okay, but the poll says downloaded and worked. Anyhow, it's okay. For me, it's neutral. If you have even downloaded, it's good enough. So we have 62% votes, and I'm still waiting for some more to respond. Still waiting for some more to respond to this poll. Um, Please do respond to this. Okay, so uh, thanks for that. I had muted, so didn't note it. So I was telling you about the distributed file systems. You must explore the DFSs from GitHub. Okay, the four that I have mentioned include Ceph, which was adopted by Yahoo. Cluster.fs is another open source project. Okay, now it is governed by Red Hat rather. Both of the Ceph and Cluster.fs are governed by Red Hat. Lustre happens to be on the top 500 list. Okay, so the supercomputing sites, they have Lustre implementation. MooseFS is quite similar to the uh, HDFS. Okay, the details of these I have mentioned in a document which has been shared to all of you, and let me tell you which document that is. So, if you refer to the document distributed file systems, okay, it's there on your screens now. Okay, have a look at this. It's a 6-page document, and we have the same four of them which I just listed. Okay, and you can have a look at the Ceph. Okay, is an open source developed project, okay, which is now very well in almost entire Yahoo now. Then you have Gluster.fs. Gluster is now from Red Hat. Okay, so acquired by Red Hat. We can see out here. This was acquired by Red Hat in 2011, and the development is in production. It's also an open source community, so it's not that you have to go to Red Hat to have Gluster.fs. Okay, and then there is Lustre. As I said, on top 500 supercomputers, it is present. And then moving on to MooseFS, which is quite similar to HDFS. So C acts as HDFS. So these are the four. Okay, apart from the HDFS. Have a look at this document. Okay, it's a good reference point for you, and I'm sure you can gain a lot from these documents that I have shared. So let's get back to our presentation. So now moving on to the Google Cloud Platform. See, cloud computing had also been very prevalent in the last about 8 years or so. Okay, 8 to 10 years. And Google Cloud has become very popular in that sense. So for example, the Google Compute Engine. So all you need to do is, in order to work on the Google Cloud, I'm just writing down. I'm sure you would be having a Google handle, okay, Gmail account. So all you need to do is go to cloud.google.com and just go on, okay, over there. So once we go to cloud.google.com, we can seamlessly get started working on applications. Now, this is one example that I'm showing you, wherein I had worked on a Google Cloud project by going into the same, so I believe now that should be visible to you. Okay. So we had this Google Cloud Platform slide just before this, okay, and previously I had been telling you about, sure, the distributed file systems, which are almost open, all of them are open source. Okay, so whether it be Lustre or MooseFS, yeah, apart from these, there is IBM GPFS also, which is in the closed source domain. So I would mention that in the chat window, IBM GPFS. That is General Parallel File System. So IBM GPFS happens to be an IBM only file system. Okay, and yes, I would like to mention here that IBM GPFS and HDFS can work together. So what IBM says is that uh, you can have your own HDFS cluster, whereas uh, we will have GPFS over the HDFS. So they say that, okay, you can go ahead having MapReduce applications, but our GPFS will be the dominant one for storing the file systems, for the files and file IO. Why? Because HDFS has certain limitations. So I'm writing that down. HDFS has certain, I'm only mentioning IO limitations, okay? So IO redundancy and IO latency based limitations. So that's the reason why some of the companies push their file system, and IBM GPFS, for example, works along with HDFS. So we can have MapReduce computations working, whereas it will work over HDFS. GPFS will be over HDFS. So have a look at these also, okay, in your spare time. And since you now get started exploring this area, I was telling you about the Google Cloud Platform, and as if you log into your own Google account, all right, Gmail, let's say, in another tab, all you need to do is go to cloud.google.com, and we'll find a similar, page as is displayed over here. And it also asks for the card information for billing, but then Google provides uh, the cloud access free, for few months, and till you do not cross that certain threshold of, let's say, downloading a lot of data and things like that. So this is a very fine, place to see. Uh, I would be happy to show you a few things, that can be done on the Google Cloud. So I just have to open that thing up. Um, So see, on the left hand side you have the source code, okay, and then you have compute, storage, and data. Everything is out there, big data. So we can even go for Hadoop based computation when you click on the big data tab here. Storage, we can have the cloud storage. So you do not store anything on your laptop or even on SAN storage. Everything is on the cloud. And then compute. So this is precisely server instances, how much RAM is provided, how much of, CPU, and how fast is a CPU, and then source code. So this is all cloud based. Okay, so cloud is another topic altogether, because when we look at the cloud offerings, okay, like PaaS, which is platform as a service, then comes, or rather infrastructure as a service is the first layer, then platform, and then software as a service. So for platform as a service, we have which is that, Salesforce as the main company, or the front runners in the market. So they provide platform as a service. So this is typically something similar. But whenever compute comes, okay, we have infrastructure as a service. Or if you have a website of your own, that will be software as a service. So these are the different cloud platforms where you can go ahead working on big data projects. So cloud and big data are very synonymous these days. Okay, because like Amazon is another example you can see. You can hire instances on Amazon and go ahead creating the projects there. Uh, OpenStack is another cloud offering these days. If you would like to work on OpenStack, I'm mentioning a website here, uh, which one can go on, obviously on the web browser, and TriStack allows you to even create your own server instance over there. It allows you to create 3 instances and even provides you with a public IP address. So this is one of the very fine sites, TriStack, to work on a open source based, cloud offering. So we'll have a look at some of the big data examples. All right. So the first one, consumer product companies monitoring social media like Facebook and Twitter, okay, to get unprecedented view into consumer behavior, preferences and perception. So we had a bit of talk yesterday about clickstream data. Every time your customers are coming to the website, uh, we can have a system that tracks most of the clicks. All right, anything that the user types on your website, and eventually purchases some items from your website. So these are what are called as customer analytics. Okay, and then you can even work on predictive analytics through these. That is what might be the customers perceptions, right? uh, since I saw very minimal of you who have worked on GitHub projects, these days the best of software projects are already there on GitHub. Okay, because some of the companies, they do prefer open sourcing their projects. So it's really about how well they are implemented, how they will connect to other projects, and how well the team does in the market. So these are the factors that uh, ultimately leads to the success or failure of both projects and companies. So second is the governments making data public, okay, at both national and international level. The World Bank was one of them. All right, I'll show a full directory, okay, of data sets available, which are from the open source domain, okay, from the public domain. So this is called as the public domain, and governments all over the world are sharing, or they are making the data public. Indian government's data is one of the best. I would be happy to write that down. Let me just tell you about the portal so that you have a look at it. So that is data.gov.in. I'm mentioning that over here. Have a look at this particular portal. One of the best sites to have data on India, right? Now, see, this one I have mentioned is the data on India, and it's highly accurate, okay, and it is certified, because who is putting the data over here? It is the NIC, okay, National Informatics Center. Because I have been associated with some of the government institutions, okay, including for big data projects, and conferences. So this data is very much certified. Okay, and you can absolutely look at it, and there is a lot of numbers hidden in this data. So just in case if you are working on a big data project, one must go through these data sets available over here. And sports team, moving on, sports team, okay, are using to track the ticket sales, even for tracking teams strategy, tracking team strategy. So even for sports, that they overseas, they make a lot of, they have a lot of analytics through which they improve, the sports teams. Manufacturers, okay, monitoring minute vibrations in their equipment. So I have also come across a similar case from Reliance of late, so that they can put a similar system for their manufacturing equipment. Reliance Industries. Financial services organizations, a similar case wherein uh, there is a lot of finance data, okay, based from banking and financial institutions, insurance companies. So for finance, one can do a lot of analytics. Same goes for web-based businesses also, because as I've just mentioned, Flipkart and other similar companies, okay, they are always doing the customer analytics when the customers are there on the website, either from a laptop or desktop console, or from even from the iPhones and other Android phones. So big data projects are all around us. It's just that we have to make a or recognize them. So most of the traditional IT skills are being moved towards cloud and big data platforms now. Okay, AI, artificial intelligence, distributed computing, supercomputing, business analytics and business intelligence, data analytics and data mining. So these are some of the related fields, where you can plan out, okay, and see slowly and firmly, as and when the IT professional climbs the ladder, he or she keeps on gathering the previous experience. So as and when you have your previous employers uh, you know work, so that you can apply the same with your futuristic goals. So that's what I again advise and advocate to all my associates. And the big data market, we have known in the last so many years, it's a $50 billion market in 2017. And then there are a number of fields that are getting associated with big data now, which mainly includes IoT and the analytics market. So if you are really interested in growing in the certification, so I suggest don't just look at the big data uh, administration and development. Analytics is the next thing to work on. So the parallel programming paradigms, I don't know who is doing this. I'm not doing this. I'm certainly not taking this to the next screen. Do you have a hand raised? Manjunath, Ranjani, Rupesh? Yeah, what is it that you would like to say? Let me know. What is it that you would like to say? Please tell me on the chat window. So you can tell me on the chat whatever your queries, otherwise I would not get to know. So next we move on into parallel programming paradigms. How is it going further? Okay, I'll have to switch to this screen, I think. Okay, so parallel programming paradigms. We'll start with this and discuss. And meanwhile, what I'll have to do is, go back. Let me switch to the workstation so that we can either do some parallel work over here, or I have another machine, okay, for doing the parallel activity. So these four machines I would turn off, okay, and move our focus to programming. So I've just shut down the different virtual machines. Let me know any doubts as of now that you may be having. So okay, so Renan is there. Yeah, let me know who all are there. So we'll now continue. All right. Okay. Hi, Amit. Okay. Rupesh, Ramakrishna, 5, Raja, Kumaran, 6, 7, Mushim, Satendra. All right. Okay, good to know that you are here. So now I'll uh, go into the parallel programming paradigm. Okay. See, up till now, we have seen distributed file system and HDFS in particular. This was mainly to store the data, right? It is only to store the data when it comes to distributed file systems. The problem arises, okay, when we have the data distributed in multiple machines. Okay, as you may have seen previously, there were about 4,100 machines, okay, in Facebook and other places. The problem arises when we have to integrate, all this data and work with this data because the data is segregated, right? It is also possible that there is a 100 gigabyte file which is spread across multiple nodes. So that's when problems start arising, and that's when even NoSQL will be more applicable. So we would have to understand the parallel programming paradigm. Okay, there is a simple difference between local and parallel. So I would rather like to use the pen here. So the parallel in local, what happens, let's say there is this local file system. We are basically making that only for one machine. Whereas when you look at the parallel file systems, we have multiple systems. Let's say these are different systems. So we have to write our parallel stuff uh, for these. So parallel programming. Now, how does parallel work? We'll have something like A over here, we'll have B over here, right? We'll have C there and D over here. This is how the data has been distributed across in different locations. In local read, it is just reading from a single hard drive. That is not a problem at all. But when you have parallel reads, it has to read from A, B, C, and D, or maybe A and B, it has to read from two separate machines. So these are the scenarios, okay, between local and parallel programming techniques. So once we look at the paradigms, parallel programming hence is complex. Okay, the development is largely dependent on the availability of adequate software and environment. Okay, so these are the different ways. Okay, parallel software development bundles are available. Okay, and these different points that you see: non-determinism, communication, sync, data partitioning, distribution, load balancing, okay, fault tolerance, heterogeneity, shared or distributed memory, deadlocks, and race conditions. These are some of the complexity problems, okay, that arise when we are into the parallel programming, what you call, techniques. So moving on is the approaches that we take. So there are two basic approaches for parallel algorithms. I would suggest you to go to my slide share. Okay, in my slide share you will find there is a tutorial that I have created in 2008, uh, which was referring to clustered file systems. Okay, our clustered file system technologies. Have a look at that, and you will be able to go through the types of parallelism or types of clusters that are created. So referring to implicit and explicit parallelism. Okay, so implicit is supported by parallel languages, parallelizing compilers, okay, that take care of the identifying parallelism and scheduling of calculation and placement of data. See, this is implicit parallelism. And explicit is where the programmer is responsible for most of the tasks, okay, such as task decomposition, mapping tasks. So this is where we do HDFS based programming. Okay, map reduce programming is explicit parallelism to processors and communication structure. This approach is based on the assumption that user is often the best judge on how parallelism can be exploited for a particular application. So I just have a question from one of you. Just like DBMS takes care of data related complexities, why doesn't same happen here? Why we have to need handle parallel data storage at programming level? So one of you have asked the question that just the way that DBMS takes care of data related complexities. See, the main difference, okay, the answer to your question here is the main difference is between the structure. Okay, the databases are limited, okay, limited to certain gigabytes, right, or terabytes at most. Take Oracle and Microsoft SQL Server, okay, Google the size limitations for both of these. Oracle and SQL Server both have limited database sizes, okay. Certain terabytes, they cannot span at all beyond certain terabytes. So second thing is their architecture is limited to shared storage. So it's possible that you can have, two servers or four servers were having these, having a cluster of a database cluster. And we can also go for database sharding. But how far can you do database sharding? Okay, you can have 10 machines with different number of shards. So shards are nothing but partitions. So it is this particular limitation that has put us into the NoSQL arena. In for NoSQL, we have parallelized machines, okay, or multiple nodes. So, and it is also called as shared nothing architecture. Okay, have a look at the Wikipedia page saying shared nothing. I'm writing it down. Shared nothing architecture. So there is a good wiki entry for shared nothing. Now shared nothing architecture means that you have, let's say, 10 desktop machines, all right. We know that each of the 10 desktops have four primary components. One is the CPU, okay, RAM, uh, network interfaces, and the hard drives. So each of the 10 desktops can have similar components, and when you network them together, okay, let's say on a 1 Gbps network. So this is termed as a shared nothing architecture. They are not sharing with them anything. No shared storage, isn't it? Nothing like that. Now comes the question of parallelizing these machines. So the challenge starts now, isn't it? So when you have these 10 machines, the best we can do is, okay, integrate them with the single network. So network is utilized, then integrate them with the what you call uh, the, the hard drives. So as we have seen the distributed file system, so integrate their hard drives. Second component is integrated. Now the most important components are RAM and the CPU, which perform the computations. So when we are to utilize these uh, two components, that's when these two features, which is implicit and explicit parallelism, arises. Okay, so implicit parallelism, we usually put them in the languages that we create, so that each of the 10 machines are networked will have the same, kind of compiler, so that when the program is run, they understand that equally. Okay, so these are called, there are different ways of parallelizing. We are going to look at those. And explicit, so this is more of developer based. Okay, so these are the strategies for parallel development. So automatic parallel libraries and major recoding. So these are broadly, okay, the network, the parallelizing terminologies. See, these are the ones I was talking about: the shared memory model, message passing model, hybrid, and object and service oriented models. So shared memory is where the memory is of each of these machines is also shared. But then when we do this over Ethernet, it is not so easy. Okay, so OpenMP has been one of the very preferred methods of message passing. Then message passing model, PVM is parallel virtual machines, and MPI. So for MPI, you have also got something called as Open MPI. Okay, so have a look at these things, these two ways of parallelizing. Now in parallel virtual machine, we can think that the cluster becomes a very large, huge machine. Okay, huge in the sense that it has, so 10 machines have got let's say uh, an i5 CPU, okay, of 2.5 gigahertz. So we have, let's say, 10 machines, 10 CPUs altogether. So that is the parallel virtual machine, PVM model, right? In message passing, it is the other way. Each of these machines will have their own operating system in sense, okay, and they will pass the messages over SSH protocol. So let's say one process starts, okay, and the process will spawn to these multiple machines, say 2, 3, 4, or 10. All the 10 machines, the same process is running, and it is dividing that job basically. The first one is the contrary. So it is not dividing that process, it is integrating these 10 machines and considering this as a single very large system. So it was also called as SSI, and if you search the term single systems image, single systems, all these are mentioned in my that tutorial. Okay, so have a look at that single systems image. That's a parallel virtual machine. Okay, so then we have the hybrid model. So you have something in between the OpenMP and MPI. Okay, and then these are the old ones, object and service modules. These are the very old ones. So here we can see that they have been given again PVM, MPI, and threads and compilers. So levels of parallelism have been given. Uh, so broadly, it's these two ways. Okay, one is message passing and one is using as a single systems image. So methodical design or stages of parallel programs. See, all of the parallel programs are partitioned. Okay, so one thing is to be kept in mind that mainly the batch-oriented programs can be parallelized. Okay, so if it is not a batch-oriented, so by I hope you understand what is batch oriented. Hmm. Even in Hadoop MapReduce, you can only do a batch oriented programs. Okay, so partitioning, decomposition of computational activities. All right. Then communication is the flow of information, how that information is passed on to different machines. And then agglomeration has the tasks and communication structure, okay, created in above stages. So the way you are creating this, and mapping and scheduling. So parallel programming in general, is quite a difficult task to perform. Uh, Obviously, once you get into a program, then you would be pretty firm to work on that. Uh, I can give you a very simple example here. I think that example we can see from the VM that we have just run. Okay, so in master, worker, and slave model, so master will decompose the problem into smaller tasks. So HDFS and Hadoop also we have the same thing, that the task will go to a resource manager, okay, and from there it will get say uh, a lot of it will get decomposed into smaller tasks. Okay, let's say one large task comes, and it will be divided into 10 smaller tasks. Okay, so that's this way of doing. And then we also have another programming paradigm called a single program multiple data. So you have multiple data, isn't it? So data is actually coming from several sources, right? And it is most commonly used model, because in parallel programming you have data spread across several nodes. So each process executes the same piece of code, okay, on different parts. Wikipedia is one of the other examples. Okay, the Watson that I was telling you, the Wikipedia dump happens to be a really large dump. Okay, and consider that the 100 GB, okay, is what you have to process. Let's say I give you 100 GB of Wikipedia XML file. Okay, if you download Wikipedia dump, it is XML file, or it extracts to an XML file, and sooner or later, we'll find that, oh my God, this is 100 GB traversing. If you see the academics, in academics, we teach the algorithm called as traversing, right? Traversing, sorting, etc. So traversing is to start from the top and go till the end. So this 100 GB, when you have to start from the top and go till the end, think how much time the CPU will take, okay? A single CPU will take. Whereas this 100 GB, when you split it into 100 machines, each has to go through 1 GB now, right? Each has to go through 1 GB. Let me see if there are any chats. Okay, and no chat here yet. So I hope you are following this. Hmm? May I hear from you? Okay, okay, that's good, that's good. Okay, I think we have done too much of theory. I think it's going to be good if we go into some practicals. What do you say? Huh? We can delve into some practicals now. Okay, and so this was the summary of parallel, computing, and we can probably move into our uh, virtual machine now. So, all right. So many of you are sending a message that okay, it's fine. We can move into the virtual machine. And something that I start now, you will really find interesting. Okay. Okay. Now, the screen that you see, all right, is that of the Cloudera Quick Start VM, okay, which I have downloaded from the Cloudera website. Let me know, have you been able to download this VM from the website? Let me know, please. No? I had given the link yesterday. I'll once again show the link. So it's cloudera.com. See, it's this link. Okay, so download the VM. Download the VM from this link, and you will get the same screen. Now, again for your info, this is a fresh VM which I have started, okay, only for the purpose of giving demo over here. Okay, so it's a very fresh VM. I have never, logged into this. I just freshly started. And some of you were asking how much RAM does it require. So see, it comes by default as a 4 gig requirement. So I just opened it in VMware Workstation and started running it. You can also open this in VirtualBox or even as a Docker image now. So those who are very expert in Linux can also download a Docker image. If you would like to see this, then I'll show it on the Chrome web browser. You would like to see? Okay, all right. So, okay, fine. So I'm just sharing the screen and let me show you. So, see, all you need to do is go to this particular URL. Okay, that's the URL where we need to go, and then from there go to the version number. Now even 5.9 is there. Okay, so 5.9, 5.8.3 is also there. I think 5.10 also you can select, and that's the latest. So and then say get now. Okay, uh, after get now you will get this screen, and so see, that's the installing the latest CDH5. So if we let me just search for Cloudera Quick Start. Now you just need to go to downloads. Okay, so go to downloads and click on Quick Start. Right, Quick Start. I hope you are noting this. Go to cloudera.com, click on the downloads, and then click on download now. So once we are on this screen, okay, see, this is where previously when I saw 5.10, it is not available for Quick Start. So Quick Start is the kind of a compressed VM that you will get. Now that's the platform for which we can download. So VMware, you are aware, the one which I am running, and VirtualBox is free from Oracle. So you can get an Oracle VirtualBox free, okay, from Oracle website. Somehow I don't prefer that because it is not very stable. Okay, VirtualBox is there on my desktop. This is the icon I have. It's not very stable. Uh, KVM can be run if you are running an existing Linux box like RHEL6 or CentOS 6. Then you can use KVM image, and the same can be started over there. But what most folks prefer is, rather than the Linux KVM, they say, okay, why not go for a Docker image? So Docker is more straightforward. VB is latest for me if you have a desktop. VB, any VB, I think VirtualBox will do. Mine is I don't remember which is my VirtualBox, but it is immaterial. So for VirtualBox also, it'll let's say if I click VirtualBox, uh, it'll give you here itself which VirtualBox is supported. Okay, so have a look at that and get that downloaded, and then you are good to go, isn't it? It's basically CentOS. So I'll show you what is inside the VM. So just say get it now, and you just need to give you a few details that this is trial and all that, whether you are self-learning, and give your name, last name. Business email can even include your personal email address, and country, job role, job function. See the job role: analytics, big data, data warehouse, data science, database. All these are the job roles you can give, and just continue and go ahead downloading this. So once you download this, uh, then you can absolutely start off with the with working. So I was just looking at the same image. So Yahoo is in fact 42,000 servers. So let's get back to our machine, and we'll do a couple of things there. Okay, so I believe you can see the screen now, and I'll go to the main screen, full window, and see in this itself, uh, you get some tutorials. Okay, so get started, and I'll click on this for now. Okay, then you have analyze your data, manage your cluster. Now, some of you may be thinking that uh, why we are running a single cluster. So just to inform you, we can use Hadoop in three methods. Okay, I'll use the gedit terminal, gedit editor. So the methods in which Hadoop can be used are in three ways. Okay, three ways of using Hadoop. So one is as a JVM mode. Okay. Second is as a standalone cluster. Standalone cluster. So standalone, or it is also called as pseudo distributed. Pseudo distributed cluster, and we can have a multi-node cluster. So multi-node cluster. Now the last one is the feature which I had shown you previously, okay, where we ran 4 nodes. Yesterday I had run the 3 nodes. That's where we are running a full-blown cluster. Whereas the JVM is nothing but the moment you download Hadoop, okay, and say you have Java already, then as soon as you run Hadoop, okay, it is running in a JVM mode. So if you do not configure HDFS, it's running in JVM mode. So I'll just say Hadoop version here. However, now the standalone is what this particular cluster is supposed to be. This machine that we have downloaded, okay, is a pseudo distributed, or it is also called as a standalone cluster. Why? Because HDFS is still there in this particular, in this, we still have a cluster. Just a minute, please. Okay, so uh, this is a pseudo distributed cluster, which means HDFS has already been configured, and this is the best place to start, because for those who are in Linux, okay, see which is the Linux version that we are running. So it's in etc Red Hat release. So that's a CentOS. Okay, it's a regular CentOS 6.7. All right, and it's a regular Red Hat system or CentOS. So you can even work on other applications. Since it is natted, so I can even ping an external website. So working on this is the best suited place. Even suppose you want to do any AI application, automation application, okay, any GitHub application, I always do it in this. So I have a very old running CDH 4.4, which is almost 3 years old, and I still haven't been able to come out of it because all my R&D goes into that itself. Right? So that's what my recommendation is. Have this distribution downloaded and do your learning activity in this. So I'll be showing some of the demos here, which are again pretty good to see. Okay, so the first one here is the Cloudera live beginner tutorial. It says, welcome to the quick start VM, and so follow this particular tutorial. Okay, and it says that with some of the tools were with CDH, Cloudera open source distribution for Hadoop. Okay, and by the end of this tutorial, you will be understand how to use some of the powerful tools in CDH, know how to set up and execute basic business intelligence and analytics use cases, be able to explain to your manager why they need to give you a raise. Okay, so these are some of the humorous, texts which are written there. So further, it says that you will need such and such. Okay, so much 8 GB RAM is required. It says, but then it runs even in less than that. So we go next into this, and there we get a question, business question, saying that your management is talking euphorically about big data, right? And you carefully skeptical, and this is what the line is. Okay, so you can have a look at this. Any successful POC needs to address something your organization cares about. So hence the first thing you need to do is to define a business question, right? And it won't take just impress your manager, and so these are just lines you can absolutely go when you have this. Now the first exercise is to ingest the and query relational data. Okay, so what is ingestion of data? Can I hear from you? What is ingesting data? Ingesting. So ingesting is uh, to insert, okay, inserting data or to import from some other, database. Yeah. So it says in this scenario, data company business question is what products do our customers like to buy? Okay. So to answer this question, the first thought might be to look at the transaction data. Okay, so we are talking of the MySQL database here. This is probably something to do with your RDBMS. And what this exercise demonstrates is how to exactly do the same thing you may already know to do with traditional database, but in CDH. So we'll go next, and oh no, I had to be there. So see, this is the, if you could just have a look at the schema, all right? So this is a MySQL schema. Okay, so I believe you would be knowing about this. So what I'll do is to go to the MySQL here. The password is Cloudera. So what we'll do is MySQL -u is Cloudera and -p is also Cloudera. I believe you should be root. So yes, so root, the user is root and the password is Cloudera. Actually, the username is retail DBA over here. So I'll first see the databases, show databases, and there it shows I'm only concerned with the database called retail DB. Okay, this is the one I'm concerned with. So we look at this, and first thing is we see the tables. So see, these are the same tables as you may have noted that are available here. So we'll start from, let's say, departments. This is the department. And if you would like to describe department, so see, that is the department ID, integer. That's the pictorial way that it has shown, right? It's a kind of a realistic schema that we have. It's in MySQL database. And MySQL is quite a successful and popular database, right? So these guys are saying that you can copy this code just by clicking the copy there and just paste it out there. So if it doesn't get copied, then still you just copy it this way and paste it like that, right? And let's hit enter. Now what this guy is doing here is ingesting data with Scoop. Okay, so Scoop is something that's used to import data from MySQL to HDFS. So I will now show you the HDFS even before we continue. So how do we see HDFS? Can I hear from you? Let me hear from you. How do we see HDFS? Guys, let's see who has responded. Nobody responded yet. So Moshin, I saw your response saying consuming. Insert is more near, more appropriate, okay, for ingestion of data. So we are typically doing ingestion. How do we see the HDFS file system? Perfectly. Wonderful. That was fantastic, Moshin. So localhost colon 50070, either that, okay, or I'll rather be mentioning, this full thing, colon 50070. So this is what would give us the HDFS. Right. So that's the HDFS. And for your information again, Cloudera has customized it in a very nice way. So we have to go in within HDFS. See, this is the entire HDFS. And just for your information again, HDFS starts from the slash, just like the Linux and Unix systems tree. Okay, from the forward slash, which is the root directory, the HDFS directory also starts from there itself, right? And within that, there are user directories. So user is equivalent to the home directory, okay, in Unix systems. So I'm in the user directory, and within the user there is Cloudera. So I'm as the user Cloudera on the host machine. So it will deem to send it into that directory. So I'll hit enter here. Let's see if this works. So actually it's I don't think it's going to work because there's a lot of spaces, I have a feeling that, yeah, that was the problem. So this is what it should be. Let's see if this runs. I have some doubts because there were some spaces, but even if it runs, then yeah, it's fine. Okay, so that another answer from Ramakrishna saying name node colon port number. Well, that's also quite right. Root FS, yeah, that's the root file system. So this is basically, running a MapReduce job. Now, internally, it is running a MapReduce job. So we have discussed quite uh, in detail on HDFS and on distributed file systems. Uh, but MapReduce, discussion on MapReduce may not be so straightforward, you see. Uh, so I can open some of the previous, see this is map 0 and reduce 0. So we can have some other uh, slide so that I can explain that to you. So let's switch to that one in the time that it completes this operation at least. Okay, so I'm just going to, for a while, switch to understanding MapReduce. Okay, let's have a look at understanding MapReduce. Okay, so I'll be able to tell you about how MapReduce works. I hope you can see this. Okay, MapReduce is a programming model. Just as we were discussing the parallel programming paradigms, all right, MapReduce is also a programming paradigm, neither platform nor language specific, okay, and record oriented data processing. Okay, and it consists of two developer created phases. One is map and one is reduce. So it will be much clearer once you finish off with this particular. So we should not be taking more than 15 minutes to complete this. Uh, so see, there are broadly two phases. One is map and one is reduce. Okay, both are programs. Okay, they can be both Java programs, Python programs, C, or any program that Hadoop supports. Uh, Now, how does it work? We are going to take an example of a word count program. Okay, I told you about Wikipedia, and that was a realistic, example. Take a smaller subset of that, something like a 10 gigabyte file. Okay, so we have a 10 gigabyte file for which we have to do a word count. That how many words are actually there in that, and each word has appeared how many times. Let's say the is how many times. So that thing. Uh, so we can do so we take the input split. Okay, so as I mentioned, that's a 10 gigabyte file. When that file is read, let's say from HDFS, it will be read in splits. Okay, so split 1, split 2, split 3, like that will be read. And our algorithm will be similar. So that is called as mapper. And mapper is going to read each of these splits, right? And the splits is nothing but that chunk of text. So then there is record reader and partitioner. These are also inside the program itself. So partitioner is what partitions the file. Then comes the shuffle and sorts. And after shuffle and sort, let's say that the 10 gigabyte file had about 10 such splits, okay, 1 gigabyte each. So how many outputs will it provide? We have 10 splits. How many output files will be there? Please tell me in the chat. I hope you've got my question. So anyhow, I'll once again ask that question once we go next. So then the reducer will run, okay? The reducer will read all the inputs that this file has produced, and finally we get the output out there. So see, this is a traditional way of putting it. In Unix or Linux, you would have seen something like cat my log. So what will happen here? The log file will get output, but then we are piping it to grep. We'll say that grep HTML. So only those lines, okay, that are having HTML will be outputs. Again, we are sorting that with a pipe. So we put another pipe and sort that out. Then some of the lines may be duplicate. So unique will ensure that only the duplicate lines are output, and then the output comes to the out file. So this is like pipelining, right? And so similar things are also put in the in MapReduce. Okay, mapper works on individual record. Reducer aggregates the result from the mappers. Intermediate keys, okay, are produced by the mapper itself, or it is also called as intermediate data. So that's automatic parallelization. These are the features, okay, and fault tolerance. These are some of the features that. So once again, we look at the basic concepts. Um, okay. Uh, so let's go to a particular program, right? Now consider we have a very big file. Now this is typically the word count example that I was referring to. Consider that word count has to take place on a 10 gigabyte file. So which is quite a large file. And what the developer does, he would create a map function first. So see, map function is going to read the split, and we'll say let map of k and v equals to for each word in v, emit word 1. Now see, this function is happening on each split. Out of 10 gigabyte, we have 1 gigabyte split. So each of the 1 gigabyte files this function has to happen parallelly. Yeah, and now when the mapper runs, okay, this is the, let's say this is the output, sorry, input to the mapper. So when the input goes as the cat sat on the mat, okay, and then there's the next line. So the intermediate output based on the previous algorithm, okay, comes to the one. So it reads the and then emits one. Cat one. So once let's reiterate the previous function. Let map of k and b. So k is the byte offset where the word is each word, okay, and v is the line and comma v. So it goes to the first word and then it says it emits that word, right, and then says one. And for each word in v, which means it goes to the next word and emits that word, then goes to the next sat, emits that, on, it emits that. So this way one mapper is working, okay, and the input to the reducer. So see, each mapper will be working like this, okay. So we'll be having 10 such mappers giving how many outputs? Tell me now in the chat window. We have 10 splits. So how many intermediate data will be there? How much intermediate data? How much splits will be there? Can you hear? No? I'm just waiting for your answer. Okay, great. 10 distinct output. That was fantastic. Thank you for that. So there's going to be 10 output for this. Now this 10 output are given to 10 individual reducers, right? The reducer will read anything that has come from the mapper, each mapper. Okay, so there is a shuffle sort that happens in between, but then the reducer is what takes the input data. Okay, if we go back, so this is the reducer. Okay, so each mapper will produce one output, and that is the input to the reducer, because reducer is also parallel, right? Reducer is also parallel and distributed. So then now when the reducer is working, so reducer will be, where is that slide now? Yeah, so that's the reducer, working, and the function, reduce function is quite similar. So it says k is the word, okay, and value is the list of ones. So it says let reduce of k, which is the word, and value equal to sum. So we are basically counting the number of times each word has repeated, okay, in that full text. So we say that sum equals to so many. So for each v in values, so basically all of the reducers are also being, utilized here. And finally, it, emits. So see the reducer output. So the has been counted 4 times, mat and all that. Okay. So this is how, this is what I basically, wanted to tell you how complete, MapReduce program happens to work. So I hope this is clear. How was this example? We can see the same thing in our this machine also. I can happily show you the example is already built into in the Cloudera machines. We can take any split, okay, and do the same computations in the split as well. Okay, so for now, I think we are just going back to our, sure, my dear, welcome. To back to the scoop, okay, so the scoop job was this complete job, right? And I can explain you what Scoop has done for us in this. You see, Scoop is one of the applications which can uh, ingest or import the data from an RDBMS. So we had a table in MySQL. Okay, I hope you can see this. We have a table in MySQL. Okay, and we used Scoop import all tables. Okay, so all tables means everything, all of these tables from the Scoop from the MySQL database. Okay, M is just one, and connect, it says JDBC and MySQL, and this is the port number, and retail DB is the database name, username and password Cloudera, and then a couple of others it says to import. So basically, it has just imported these in the uh, HDFS. More so, we can see that in user Hive, because further to this, we have some stuff to do on Hive. So we will run Hadoop FS ls and see what has been imported or ingested. So see, this is what it has just ingested. Okay, in case you would like to verify from the timestamp. Okay, so this is 3:28. It's PST, which is the US time, and here we have something like 3:14 or something. So we have these tables, okay, Hive, warehouse, categories, customers, departments, order items, and orders, which have been imported in Hive in HDFS. And even more so, if you would like to see what's inside each of these, okay, so it says you can view in categories or any other place, let's say customers, okay, we'll have a look at what's inside that. And uh, so that's the Parquet file, and we can even further see what's inside this. So you can always do Hadoop, this thing, and then cat. Okay, so you can do cat and then the file name. So yeah, Parquet file is what is the real file, because others are. So I can't really see. I think it's going to be more of uh, anyhow. So we have the data ingested from RDBMS. And next it says is go to your Hue. Okay, so Hue is another very fine feature of Cloudera, which provides us an option to work only in the graphical screen. So almost all of the stuff is provided in the graphical screen, and we don't have to bother about going in the text. So Cloudera is the login. So that's the Cloudera login. I'll just terminate this window because that was data not understood. So it was data file. So when you log into this, I hope you are following this uh, on the chat, please. I hope you're following. Okay, okay, good. Okay, so uh, the next thing that the tutorial says is, okay, start your Hue, okay, and then it says that once you are inside of Hue, click on Query Editor. So we are basically going into the Query Editor, and within that, I think we are going into Impala there, right? So that's Impala. Impala happens to be a query editor like Hive itself. So I'm going to Impala, and which is a very fast query editor. And I think we can see this example, and I'll leave the rest to you to work on, because you would be excited to work on these. Okay. It says go to Impala, and quickly it says to just invalidate metadata. So some of the previous queries that have happened, invalidate that. How about taking small break for tea? Okay, we can take a tea break in some time. Let's just finish this out and then can break. So from here you see all the departments and things are there, and so it's telling us to get the most popular product category. So we are going to write a query, okay, which is going to get the most popular product category. So which is the product which is most selling? Okay, so that is what it says it wants to run. So that's the query, and here I'm going to run the. Okay, I think we can take a break. Meanwhile, you can have a look at the output for this. I think we can come after 10 minutes. Would that be fine? Yeah. Okay, let's get started. Let's continue then. I hope all of you are back. I've got response from a few of you. Great, good to know. Okay, there are some very, very enthusiastic guys over here, and I admire that. Curious, full of energy. Oh yes, let's have a poll, isn't it? Let's have one more poll, one quick poll. Okay, guys, I just have one more poll from all of you. So we have 32, 33 people right now. Let's hear regarding this poll, which I'm just launching. Are you below 28 years in age? This I've asked mainly because uh, since you have uh, about the GitHub project. Okay, so GitHub project, I would like to know from you whether you are interested to work on GitHub projects. If you are below 28, I do believe that you can devote a lot of energy and lot into development. Okay, so I'll just move on. Hey, thanks for that. We've got good responses on this. So 60 says, well, I don't want to really be open on this. It was just to ensure that, how many people are over 28. And well, in my eyes, energy does, count in terms when it comes to development in IT industry. So let's get back to our virtual machine. We have some more time to devote to our today's session. So I'm closing the poll and I'll be sharing the same. So I've just shared this across to you. You should be able to see on your screens. And let's move on to our virtual machine now. Any doubts, any queries? Let me know, please. Okay, so good to know you are interested. Now back to our VM, all right. Since in Impala, so I would suggest that you should go and download this particular, virtual machine. I hope all of you can hear me. So have this virtual machine ready and see Impala. Okay, this was Impala. Now, for those who are into DBA, okay, you would have understood this query. Select C dot category name count, okay, as count from order items. So order items happens to be the table, all right, which you have seen. An inner join, it's doing an inner join between the products ID and the categories. So we are basically, getting the top performing product, okay, and it comes to be as cleats. So the other products happen to be men's footwear, women's apparel, and so on and so forth. These are the different categories. Okay, and we'll go back to the tutorial and see what they say there. Um, so so this is, the top performing product, and when we go further to the next exercise, okay, you would find that they want to do some analytics. Okay, so so Hadoop is definitely, one way through which we can perform a lot of analytics, a lot of data management, data handling, data processing. Um so this session is recorded, so I am hoping it will be in share. Well, so the session is recorded, and it's yeah, I'll look at it if we can, share this. Uh, Now we just saw the Scoop, exercise. Scoop is one of the only tools, one of the tools in the Hadoop ecosystem. If you go back to the slide where we saw, yeah, the slideshow I will definitely share. Okay, so you can have a look at the slides. If you go back and see the slide showing Hadoop ecosystem tools, okay, so Hive, Pig, HBase, all these happen to be the different, uh, databases. So besides these, I'll also be telling you about the NoSQL databases. So NoSQL databases, all right, happen to be in different categories. You have the HBase as one NoSQL database, and if you would like to work on HBase in Cloudera VM, you very much have a HBase, tab, and we can go into Hue, and within Hue we can go to the query editor and rather data browser for HBase. So go ahead and click on this one. Okay, so there we have the basic, HBase thing. So you can even do database schema designing in HBase over here. Due to some time limitations, I am not going to be able to cover each and every aspect of a NoSQL database, but I would definitely tell you that you can install almost all NoSQL databases in this very VM itself. Okay, because it's a CentOS, and CentOS you can install the MongoDB, then uh, Cassandra, then MarkLogic, then your Couchbase, okay, so CouchDB and MongoDB. So these all can explicitly be installed. If you need some reference manuals and help, you can always check with me and my SlideShare account. So on my SlideShare, I will also be putting some more material so that you can get started with each of these. So for now, if we have to work on the HBase, we can always go for new table and say I'll put it as a test table. Okay, so something like test T1. Okay, and then we have to define the column families. So let's say that if I put as the phone number, then I can add another column family here. So this is not required. You can just add another family. So rather than phone here, let's put it there. I'll say the name. Okay. Then we add another. So something like email. Okay. So this is how we we would normally just make a table schema, and I'll just hit submit. Okay. So this the test T1 is what happens to be our table schema, and we can absolutely add new rows to this. Okay, so you can add a new row, and so uh, so row key we can say something like say L name or something like that. Yep. Who is that now? Okay. Now, so see, this is how we can create a schema in HBase. Because HBase is a part of your CDH already, we can do this. However, in order to install other NoSQL databases, you can absolutely check the GitHub.com website, the ones that I have mentioned. So over there, you can go and install it from there. So you should be able to browse the net from your VM, and you should be able to download. So one other thing that was left out was running a MapReduce program. The MapReduce program that this ran was through a scoop. Okay, so since we have come to this tutorial point now, you can see if we moved ahead, in this tutorial, it says that by introspecting the results, okay, you quickly realize that the list contains many of the products on the most sold list from previous tutorial steps. But there is one product that did not show up in the previous result. Okay, so it says this is missing. This one is missing. So so when out of by going through these lines, you will find that there was a particular typo in the full paths. Okay, so why? Because the guy was going and clicking on this. Many people were going and clicking on the top product, but they were not able to buy it. Why? Because there was a typo in the full path. So when they clicked, they didn't really get to the page where they can buy it from. Okay, So that's the major reason. I'll just search for this word buy. Uh, so you will find that that's the reason, why it was a top selling product, but it didn't really, sell for these last 1 month. Why? Because that there was a typo. So going further, you can find a lot of other, tutorial points in this. This tutorial exercise 3 also, wherein you have Spark language. Okay, so Spark is a new tool. Okay, as well as a platform. So either you can use Spark or MapReduce, right? So these are the two ways that we can use. It's all copy and paste that I would need to do over here. So I'm also here to show you a MapReduce job for a word count program itself. So it says that we shall run a word count program in this exercise, and so these are some of the. There is a particular file called as Shakespeare.txt. So we can take any file for that matter, and then this is what we have to perform. So I'll first create a directory as input, okay, and this will go into the HDFS, and we'll have to figure out one file. So what I'll do is just copy, the etc services. So let's have a look at etc services /etc/services. So let's just put this particular file, okay, in the particular directory. So next is -put, uh, which is this file in inputs directory. So as per the text, put Shakespeare. So rather than Shakespeare, we are just putting the etc services in input directory. So that's going from local into the HDFS directory. And then we'll have a look at the input directory itself, right? Let's have a look at the input directory. So there we have the services file, and now the last thing is to find our real MapReduce application. So Cloudera by default provides you with the MapReduce application, which is in the example.jar. So that's its finding. Now, meanwhile it finds, I'll show you the port number 8888. So we'll have a look at, so that's also not required. It's a little bit slow because many things are running in the background. So this is what is running in the background. So somehow it's not founded. Let me just check this particular jar file. So those who have worked on Java would understand jar. Okay. So see, this is one jar file, and you can use jar, okay, to see what is in there. So jar-tvf I'm doing to just see what's in the jar file. I guess we can do just star hyphen. No. So anyhow, what we'll do is now run this. Okay, so in order to run any of the Hadoop files, we do a Hadoop jar, okay, and then give the full path, which is supposed to be this, right? This is supposed to be the full path. and then we are going to make use of the word count application. Okay, so this is the word count application, and then give input as the directory. Okay, and counts as the output directory. Okay, I hope this is clear, that word count as the module in the jar file, and then input and out and counts. So see, this is the typical application which we can administer in port number 8088. So if you see the 8088, which we haven't really come across previously, I told you about 50070. 8008 happens to be the port number for resource manager, which is the applications. So the one we just now run, okay, is a MapReduce application itself, and says number of splits is 1. Okay, and here we should be able to see that application. See the word count application. This is the typical word count application which was just run, right? And according to the very word count algorithm that we had seen previously through the slides, so it's going to run a mapper, okay, and then a reducer. So if you are interested to see the code of the mapper and reducer, they are very much available on the net, on the Cloudera website also. So this can be looked at this screen, just the way we had the HDFS screen. We have the map reduce in a similar way. Okay, in the time that this guy is running, let me have your views on this particular site. Okay, I'm mentioning one URL. So go to the URL and let me hear from you. So guys, go to this URL, okay, and fill in a survey. Okay, so it has just got completed, all right, and you would be able to see from here some of the output. Okay, so as soon as I ran the MapReduce Hadoop MapReduce examples, now what goes in as the input is the input directory, and input directory we have nothing but what is in the input directory. It is this same services file, right? And from there on, what we can do is have a look at the counts directory, isn't it? So I'll once again show you. This is the counts directory, isn't it? And we'll have a look at Hadoop FS ls counts. So let's have a look at the count. See, this is the counts directory, okay? And I'm now going to use within Hadoop, we find the more, same as in Linux. Much of the things are like in Linux. So we can do like this. I think tail is there. More is not really there. So we can make use of cat over here. Okay, so this entire thing, all right, happens to be coming from the counts directory. I hope this is clear. Now, I would like to make this more clearer by actually, starting, let's say, the same file. I'll open in etc in the VI editor, okay, and here let's go for the UUCP, okay, or something similar. Let's say using, okay. So I'll start with the search string using, okay, and hit enter. So see, two of them are here, two, and the four over here, right? So the using has come 4 times. Two on line number, I think 50, right? And there. So I hope this is clear that the word count, okay, has been made possible through uh, something which is already there in the VM. Okay, so guys, we are almost concluding this. Okay, the use cases for the big data applications. Have a look at the file which I had shared. Okay, and you should be able to have a look at the 6 use cases. I hope all of you have seen the particular file that was shared. So have a look at it. Fill up the survey that I've shared. Okay, I'm looking forward to see the survey that has been shared in this just now. Okay, and so let me know if you are having any further doubts besides, uh, I've heard from you. So it's been quite a active audience. Right? Guys, are you filling up the survey? Okay, okay, good to hear. Cannot open. Well, it should. It should open. So any further questions you have, do let me know. Okay, I have sent you my email address yesterday, and I would be happy to hear from you. In case if you start off with any project, let me know. If you can share few things, I would be happy to know from you. And I hope these 2 days have been knowledge, expanding experience for you. So although I've had to, speak continuously or more or less for these 4 hours, 3-4 hours, but as you write, I really feel good, and it is good to know that you are, learning from this webinar. Yes, I think the feedback link will also be there provided to you. So I think that will come in a separate mail, right? So this is a survey questionnaire which you can fill up, and let me know if you have any questions, further to this. So it was nice having you all, and I wish you all good luck. Okay, and uh, stay in touch, and look forward to hear from you. All right, guys. Okay. Yeah. Thanks for your time, Raja Kumaran. Thank you, Radhe. Yeah. Sure. Sure. You can get to me for any doubts, okay? Because I've been into the training industry for about 12, 15 long years, including, some of the projects into IT, like systems integration jobs and implementations. So I've already sailed through the boats that you are into, and we usually require some or the other focal areas wherein we can concentrate our energies. So take big data as just the industry, okay, and I'm sure that you would have gained much from these days, and the material that has been shared through the training link, that should also give you some insight into which what kind of projects the companies are making and would like to develop. So anyhow, it was nice to hear from you also. Um, let's see if we can meet sometime. All right. Thank you again, and have a nice evening. Well, this is Manish, not Mithan. So this is Manish here. It's